So consider the following grammar and you have to derive a string in this. So in the previous three we saw how to do leftmost derivation, how to do the rightmost derivation, and how to draw the derivation tree. Now in this lesson we will learn a new part also, how to check whether the grammar is ambiguous or not. So we'll check the ambiguity or the non-ambiguity of grammar. So first what we'll do, we will solve this using leftmost derivation. So E will be, we'll say E plus E. So first we'll change this E changing to ID. So ID plus E. Now we need a multiplication between the two IDs. So E changed to E into E. We get ID plus E into E. E changes to ID. ID plus ID into E. E changes to ID. ID plus ID into ID. This is your final expression. We will also try leftmost using or we will try it using E changes to E into E. So we need a plus, so we say E changes to E plus E. So here we'll write E plus E into E. E changes to ID. ID plus E into E. E changes to ID. ID plus ID into E. E changes to ID. ID plus ID into ID. This is your final expression. This is what ID plus ID into ID. We will also check for rightmost derivation. Expression given to us is E changes to E plus E or E into E or ID, and we require what? ID plus ID into ID. So we'll do this. First we'll see E changes to E plus E using rightmost, and we also see E changes to E into E using the rightmost. So rightmost is this. So I will say where I want a multiplication. So E changes to E into E. So E plus E into E. Then I can say E changes to ID. So rightmost E will be changed. So E plus E into ID. Then again I will say E changes to ID. So E plus ID into ID. Again I will say E changes to ID. So ID plus ID into ID. This is your required expression. Now this I will try using E into E also. When I do this, what will I get? E into, change E to ID. E into ID. Next step, E changes to E plus E. So E plus E into ID. E changes to ID. So next step, E plus ID into ID. Next step, E changes to ID. So ID plus ID into ID. So now this also we got as same. Now we'll draw the tree, derivation tree. We'll draw for leftmost only first. Rightmost is simple. So we'll draw for leftmost derivation tree. We'll draw for E changes to E plus E first. So you have E changes to E plus E. Now E plus E changes to ID. E changes to ID. This E changes to E into E, and eventually they change to ID. And second is for OR. E changes to E into E. So you have E into E. First we need a plus. So we'll write E plus E. E changes to E plus E. Then this E changes to ID. E changes to ID. E changes to ID. So what do we conclude? We conclude that there are two derivation trees, as there are two different ways of drawing the same output or the same start production. So we have two different ways to get the output. In this also you saw, you are using E plus E also you are getting the output, using E into E also you are getting the output. For leftmost also, if you are using E plus E you are getting the output. If you are using E into E also you are getting the output. So we say that there are two derivation trees possible for leftmost, two possible for rightmost. So there are two different ways, one is E plus E, one is E into E. So therefore we say that the grammar is a ambiguous grammar. When do we say that the grammar is ambiguous grammar? When you have two possible ways of deriving the output. So we conclude here, we conclude saying there are two derivation trees, as there are two different ways of deriving. One is what? The one output was what? ID plus ID into ID. For deriving this one output, for leftmost derivations you have two different ways, even for rightmost you have two different ways. So basically you have two derivation trees possible for one leftmost derivation only. One, that is one for one output you have two different ways, using start production as E is E plus E, or E is E into E. Thus, the grammar is ambiguous. When do we say that the grammar is ambiguous? When you have two possibilities, two productions for deriving the same output. You have two derivation trees possible. Therefore, we say that the grammar is an ambiguous grammar. So, you start with E plus E or you start with E into E. You are getting the output. So, we say that the grammar is a ambiguous grammar because there are two derivation trees possible for the leftmost derivation. So, for a single derivation, if two derivation trees are possible, then we say that the grammar is a ambiguous grammar. So, we'll write the CFG for a language is said to be ambiguous if there exists at least one string which can be generated in more than one way, which can be generated in more than one way. So we saw that there was one string. What was that one string? ID plus ID into ID, which was generated in more than one ways. And what were the ways? E will be E plus E or E into E. In both these ways, this string was generated up. So it was generated in more than one ways. That means there can be more than one leftmost derivations, more than one rightmost derivations, and also more than one derivation trees. That means there can be more than one leftmost derivation, we saw how many leftmost derivations? We saw two leftmost derivations in the previous example. More than one rightmost derivation. In the previous example, we saw there were two rightmost derivations and more than one derivation trees, and more than one derivation trees. In the previous example, we saw that for each type of derivations, number of trees possible were 2. Associated with such a string, associated with such a string. So now I hope the concept of ambiguity is clear. When is it said ambiguous? When you have more possible ways to derive the same string such that you get more than one leftmost derivations possible, more than one rightmost derivation possible, and more than one derivation tree associated with such string.